So we are starting chapter 5 today. Chapter 5 is over systems. So what we do today and tomorrow is 5.1, and this is just your basic solving systems, what you learned in Algebra 1. So graphing, substitution, elimination, 2 equations, 2 variables. And then Thursday and Friday we'll do 5.2. So 5.2 is 3 variables. So it'll be x, y, and z. So it'll be 3 variables and 3 equations. We will quiz after that. So next Tuesday we will quiz. And then we have 2 more sections, nonlinear systems. So that would be like a parabola and a circle. And then systems of inequalities. So there's only 4 sections in this chapter, but they're pretty big sections. So kind of still a lot of material. There will not be a no calculator part of your test. You'll be able to use your calculator for everything. Okay? So you don't need to worry about that. Okay, so if we look at what's on 5.1, verifying ordered pair solutions. So this is just plugging in x and y, making sure it's true for both. Okay, so that's nothing difficult. We don't need to go over that. You just plug in x and y. We'll do that anyway when we check our answers. So we'll start with graphing, and then we'll do substitution elimination today. And then tomorrow we'll look at those special cases of systems, and then F would be word problems. So we'll do E and F tomorrow, but we'll do just our basic graphing, substitution, elimination today. All right, so the reason why I said you'd want some graph paper is because you'll want to be able to tell where they intersect. So when we solve a system, we're looking for where the equations, where the functions intersect. We'll write our answers as ordered pairs x comma y. Okay, so what we want to do is we want to go ahead and change these to slope-intercept form. Now it is possible to find x and y intercepts and graph that way, but once we get to inequalities, we're going to want to have it in slope-intercept form. So slope-intercept form is y equals mx plus b. So that means solve for y. Get y by itself. So if I look at this first line, the first thing I want to do is subtract the 2x. Since it goes mx plus b, I'm going to put the negative 2x first before the 7. So negative 2x, and then that's positive 7, so plus 7. And y is almost by itself, but I need to divide everything by 3. And I am going to separate these terms. So when you divide, keep these as reduced fractions. So negative 2/3 x, and then plus 7/3. So my y-intercept is where I start. So 7/3, I just have to go as close to that value as I can. That would be 2 1/3, so a little over 2. Then negative 2/3 is my slope. Slope is rise over run, and it's negative, so you either need to go up and left or down and right. So one negative direction. So if I go down 2 and then right 3, be right here, down 2, right 3, or I can go up 2 and left 3. You're not sure exactly where these lines are going to intersect, so you want to make sure you draw your line all the way through your graph. Okay, now the second line, we're going to do the same thing, get y by itself. Okay, so Carly, McKay, what would I do first to get y by itself? Okay, subtract dx. Good. Okay, so I'm going to write that as negative x plus 8. And Austin. Okay, divide everything by negative 3. So what do I get here, Austin, when I divide negative x by negative 3? Okay, but what's the number in front of x? 1. So I'm going to get 1/3 x. And the reason why I want to write it like that is so I know what my slope is. Okay, and then 8 divided by negative 3 is just going to be negative 8/3. So Shelby, what's my y-intercept? Okay, negative 8/3. So that's negative 2 2/3. Okay. And then Shelby, my slope. So that means I would go up 1 and right 3. Or you could also go down 1 and left 3, so 2 negative directions, because negative over negative is positive. So make sure if your slope is negative, like the red line, then your line should be going down. If the slope is positive, the line should be going up. So just be careful when you're doing your graphing. Okay, so when you are doing this, you should get these to intersect at a point you can tell where it is. So either integer values, so like whole numbers, or at the very least, halves. Okay, so you're not going to have to guess like where 3 3/4 is. All right, it's going to be obvious where they intersect. Okay, so it looks like it's right here. So that is my solution. That is my answer. We write our answers as ordered pairs. So parentheses x comma y. So 1, 2, 3, 4, 5, negative 1. So this is my solution. Now, I can tell if that's correct or not by checking. So check your answers in both equations. So I'm going to plug in x and y into both equations and make sure I get true statements. So 2 times 5 minus 3 times negative 1. And then I want to make sure that that gives me 8. So type that in your calculator, the left side. So 2 times 5 minus 3 times negative 1. Hit enter equal. And, oh. Yeah. Okay, well, it doesn't equal 8 because that's not correct. Thank you. So, yes, it does. does equal 7. I don't know. Sorry, this one. I wrote like a combination of both equations. So it should be 2x plus 3y. So 2 times 5 plus 3 times negative 1. That should equal 7. Okay, so make sure you copy those down, right? Earlier today I was having issues with negatives. I kept forgetting negatives. So I don't know what my deal is. Okay, so then the next one, 5, this one is 5 minus 3 times negative 1. I want to know if that equals 8. And it does. So therefore, my answer, I know, is correct. So some problems will tell you to show that check or verify your answer is correct. So like on the quiz, there's a problem that tells you to do that. So this is how you would show that. Okay, this is the work you would show. If it doesn't tell you to do that, you should still do it. At the very least, just type it in your calculator. You don't have to write it down, but at least type it in, and so you can make sure that your answer is right. Okay? Questions about that? Okay, so we're going to move on and do substitution. So the graph paper you'll want to hang on to. We will be graphing more once we get to 5.3 and 5.4. We'll be doing quite a bit of graphing there. All right, so when we do substitution, it might not necessarily be set up for us to start with substitution. So I might have to get it set up to be a substitution type system. What that means is you want one variable by itself. So let's pick the easiest one to do that. So if you look at your two equations, top and bottom, which equation would be the easiest to get a variable by itself? The bottom. And what variable would I want to solve for? X. Because all I have to do is just add that 3y over. So that is what I want to do. I'm going to add 3y to both sides. So therefore, this will be x equals 3y plus 8. So I'm still going to write the 3y first. If you wrote 8 plus 3y, that's not a big deal with substitution. Graphing, you want to have that x first, but the substitution doesn't really matter. Okay, so add 3y, so 3y plus 8. Okay. So now, I want to solve one equation. So I want to plug this in, this 3y plus 8, into the top equation, since this is the bottom one. I have to use the other equation. And I want to plug this box, this 3y plus 8, in for x. It's x equals this box, so this 3y plus 8 goes in for x. Okay, so I no longer have x. So when I write that out, that 2 is multiplied by the box, so I have to do parentheses 3y plus 8. Okay, and now plus 3y equals 7. You know you plugged it in for the correct variable if you just have one variable, you just have y. If you accidentally plugged it in here for 3y, then you would have 2x and you would have a y. And then you're not any closer to getting the right answer. You have to make sure that when you substitute it in, you just have x's or you just have y's. All right, now we solve for y. So let's distribute. So 6y plus 16 plus 3y equals 7. Combine like terms. So remember, if they're on the same side, you just put them together, you add them together. You don't add the opposite or change the sign or anything. So 6y and 3y is 9y plus 16 equals 7. Subtract 16. So 9y equals negative 9. So y equals negative 1. Okay? Yes. Yes. All right, then back substitution means once you get a value, plug it back in to find the other one. Now, the easiest place to plug it back in is going to be this here, what you originally had in your box to substitute. Now, you can choose one of the originals. So when we get to elimination, I almost always go back to one of the originals, but this is going to be the easiest one for substitution. Okay, so y equals negative 1, so I plug negative 1 in for y. So x equals 3 times negative 1 plus 8. So x equals 5. Write your answers in ordered pair, and then check your work. So x comma y, so parentheses, 5 comma negative 1 parentheses. This is the same system that we graphed, so we've already checked this one. We're good here. Okay, when you do this, these on Schoology, so your Schoology assignment is going to open up on Thursday. Even though we don't get all the way through the notes until Friday, these problems, as you can see, can be kind of long. So that's why it's opening Thursday, just to give you a little bit more time. Maybe you want to get started on it, at least do the 5-1 stuff. But if you have to type this in, you type it in just like this. So parentheses, 5, comma, negative 1, parentheses. No spaces, okay? But you do need to include the parentheses because it's an ordered pair. Ordered pairs have those parentheses. Okay? It says that on the problem to type it in like I just told you, but I'm telling you also here in case you missed it there. Okay? Okay. So what I want to do here is let's just decide which equation and which variable we would solve for to do substitution. And then we'll actually do the whole thing on 32 and find the answer. So the 28 and 30, we'll just choose which one we should solve for, but then we won't actually solve it. All right, so 28, would I use the top equation or bottom equation? And which variable would I solve for? X. So bottom equation, solve for X. On 30, would you use the top or the bottom? And which variable? Y. Okay. 32, top or bottom? Bottom, and which variable? Y. Okay, so on 32, I do have to remember though that there's a negative, so a negative 1 here. But it's still easier to divide by negative 1 than it would be to divide by 8 or something else. Okay, so let's do 32. Okay, so I want to take this equation and I want to solve for y. So if I subtract 8x, I I get negative y equals negative 8x plus 6. And when you divide by negative 1, you're just switching all of your signs. So positive 8x, negative 6. Okay. So I want to plug 8x minus 6 into the top equation. And Jacob, what variable will I plug that into? The y. Good. Okay. So instead of y, I'm writing 8x minus 6. So that's 2x plus 5 parentheses 8x minus 6 equals 5. All right, let's distribute. So 2x plus 40x minus 30 equals 5. Okay, combine your like terms. So that gives you 42x minus 30 equals 5. Add 30. Divide by 42. Okay, when you did this in Algebra 1, you almost always got whole number answers, integer answers. But now that we're in college algebra, we know that most problems that you do, like in the real world, are not going to be whole numbers or integers. So getting a fraction or a decimal should not scare you, okay? It's okay to get those answers. You can plug your numbers in to check. Leave them as fractions so you don't have to round, because when you plug it back in, if you rounded, then you're not going to, it's not going to check out right. Okay, so 35 over 42 as a reduced fraction should be 5 over 6, 5, 6. Okay, now I need to plug this back in. So I'm going to back substitute now. I'm going to plug 5, 6 in for what variable, Lauren? Okay, and I'm going to use the box because that's the easy one to plug it in for. Just type it in your calculator. Keep it as a reduced fraction. Improper fraction if applicable, not a mixed number. You need improper fraction. And so this was 2/3, I believe, right? Yes. Okay, 2/3. So then my answer, x comma y, 5, 6, comma 2/3. Let's check. So I'm going to go back to the original. So 2 times 5, 6. Plus 5 times 2/3 does that equal 5. So just type in that left side, hit enter equals. Did we get 5 there? Okay. So because you can check your answers, that's why the fractions should not scare you. So 8 times 5, 6 minus 2/3. See if that gives you 6. Does it? Yes. Okay. So I'm verified. I know I'm correct. Always do your check back into the original because maybe your mistake came here. So if you go back to an equation you've changed, that could be where your mistake is, and if you plug it back in here, you wouldn't catch it. So you always go back to the original to do your check. Okay? Questions about substitution? All right, time to do elimination. Go. So when you eliminate, you're going to want to either add or subtract your equations to eliminate a variable. So when we eliminate a number, we can eliminate by subtracting the same number or adding the opposite. So adding 5 and negative 5, that eliminates, that gives you 0. Subtracting 5 minus 5, that gives you 0. Okay. So if I add these two equations together, would a variable eliminate? Yeah, so the y would eliminate. And they're opposite signs, so I just have to add down. So I add everything down. So those eliminate. And then I get 2x plus x, which is 3x. 7 plus 8 is 15. Divide by 3, and x equals 5. Okay, just like substitution, back substitute that value in. Go back to one of these originals. It's x equals 5, so 5 goes in for x. The 3y, here, go back to the original, so that 3y is still there. So 2 times 5 plus 3y equals 7. So 10 plus 3y equals 7. 3y equals negative 3. Y equals negative 1. Okay, again, this was the same problem that the very first problem we started with the graphing. So I have checked negative 1 already. Okay, so that's the way we would want to do it. That's the easy way. But let's say we were eliminating x's. Well, I would first need to multiply the bottom equation by something. And because I need the same number. So what would I multiply the bottom equation by? If I wanted the x's to eliminate, what would I multiply the bottom equation by? Okay, I can multiply it by 2. And then they'd have the same sign, so I'd have to subtract. But if I want to add, and I usually do try to add just because you're less likely to make mistakes, I will multiply by negative 2. So the multiplier I would use would be negative 2. So I multiply the whole bottom equation by negative 2. So that's negative 2x plus 6y equals negative 16. I'm going to cross this one off for now. And then my signs are opposite, so I can add. So that gives me 9y equals negative 9. Y is negative 1, which I knew it was negative 1. I already did the problem here. You back substitute and you get x equals 5. Okay. Okay, so we might have to multiply an equation sometimes. Okay, so I want to be able to add or subtract because that's the easiest. So if I look at this problem, can I eliminate a variable by adding or subtracting? Yeah, I can do the y's. And would I add or subtract those? Add. Signs are opposite, so we add. Okay, so the y's eliminate. That leaves me with negative x equals 18. Divide by negative 1, so x equals negative 18. Back substitute. You can do either equation. I usually just do the top, but you can do either one. Okay, so you plug in negative 18 for x, and then you get negative 36 minus 4y equals 8, so add 36. Divide by negative 4. You should get negative 11 for y. So then your ordered pair is 5 comma negative 11. I don't know. I was so used to writing 5. I'm sorry. I was so used to writing 5. So negative 18, negative 11. Okay. Type those in. Make sure they work. So you just type in 2 times negative 18 minus 4 times negative 11. Hit enter equals. Make sure that's 8. And then negative 3 times negative 18 plus 4 times negative 11 equals. Make sure that that's 10. Okay? Yes. Yes. Okay, so then the next one. Can I eliminate by adding or subtracting? Yes. Which variable would eliminate? The x. So the signs are the same, so I have to add or subtract. Subtract. So think about that. Signs the same, subtract. So same and subtract both start with s. So keep that in mind when you're doing these. Just be careful when you're subtracting. I have to do negative 5 minus negative 10. Okay, so every term has to subtract.
Excuse me, Miss Cecil, could you send Jacob to check out at attendance?
Yes.
Thank you.
And then 5 minus 30 is negative 15. So y would be negative 3. Okay, back substitute that. So go ahead and work this one out the rest of the way. And check your answer. Okay, 3x equals 0, so x should be 0. 0 is a number. It's okay to get that as an answer. That does not mean that it's going to be no solution or infinitely many solutions. We'll look at that tomorrow. If you get a x equals or y equals 0, that is a number, that is a solution. It's fine, okay? So my answer is 0, negative 3. You guys get that okay? Good. All right, we're going to look at a couple more. So the directions here say solve using elimination. Then it says, in some cases, the system must be first written in standard form. So standard form is ax plus by equals c. So what that means is that your variables and your constant and your equals all need to be lined up. So I need to rearrange the top equation so the x and the y are switched. So that way I can have everything lined up the way it's supposed to be. So I'm going to write negative 3x plus 5y equals negative 5. Okay. Now, can I eliminate by adding or subtracting? Yeah, would I add or subtract? And what eliminates? Yep, good. So that's 7y equals 14. Okay, so solve this one the rest of the way. Y equals 2. And then you can choose any of these three to plug it back into. I like to pick an original just in case I made the mistake when I rearranged it. I'll still go to the top, just I gotta be careful, find where my y is. So 5 times 2 minus x equals negative 5. So I got x equals 5. My ordered pair is 5, 2. Okay? Questions about that? All right, let's look at one more. So first, check that it's in standard form. So is everything lined up? Yeah. Okay, so we can start our elimination. Can I eliminate by adding or subtracting? No, I'm going to have to multiply, and I'm going to have to multiply both equations. So you can choose, since you have to multiply both, you can choose x or y. I'm just going to do x. And the easiest way to do this is to just switch their coefficients. So I'm going to multiply the top one by 0.3, 0.3, I mean 0.3, 0.3, same thing. And the bottom one by 0.2. Now, I like to add, so I want opposite signs, so I'm going to make one of those negative. You don't have to do that, but then you'd have to subtract. You could also make, because of the decimals, you could also make this problem easier if you multiplied by like negative 30 and 20, because that would move your decimal place over. But you don't have to do that. Okay, this will work. You can use decimals since it started with decimals. Okay, so let's multiply everything by negative 0.03. So it's negative 0.3. So it's negative 0.06x minus 0.09y equals negative 0.24. Okay, so I took care of that one. Now I'm going to do the 0.2. So that's positive 0.06x plus 0.08y equals 0.26. So I'm going to go a little fast here just to make sure to get through this. You can check your work in the calculator. I did just do this problem last hour. So that's negative 0.01y equals 0.02. Divide and we should get y equals negative 2. -2. Plug that back in for y. Again, I like to go to the original. 7 maybe was the answer. Let me check real quick. Yeah. 10. Did you guys get 10? Did I finish this up? You might have finished it. Okay, 10. So 10, did you find them? So negative, or 10, negative 2. Okay. So tomorrow we'll do special cases and word problems. And that's where we will stop.